In this video, we're going to explore volumes of similar shapes. So when we're talking about volume, we're talking about three-dimensional objects or solids. Let's have a look at the first point. If two corresponding sides of two similar solids is in the ratio m to n, then their volumes are in the ratio m cubed to n cubed. If you've viewed the video on areas of similar shapes, it follows a very similar theory, in fact. I guess another way to look at this is that if you double the dimensions of a prism, what happens to the volume? The volume would increase by a factor of 8. In other words, 2 to the power of 3, 2 cubed. So if you took, say, a rectangular prism, a random rectangular prism, x times y times z, and you doubled the dimensions. So when you say double the dimensions, every dimension has to be doubled equally, or multiplied by the same factor, scale factor of 2, obviously here. So instead of x, we have 2x for, say, the length. We have 2y instead of y, okay, for the depth, and 2z for the height instead of z. So the volume of the smaller prism is just x, y, z, x times y times z. The volume of the larger prism would be 2x times 2y times 2z, which will give you 8xyz, which is obviously 8 times the volume of the smaller prism. Okay, so you could even demonstrate this with a cube. If you had a cube, for example, of side length 1 and you doubled it, okay, what would the volume of the new cube be? 2 times 2 times 2. So this one would be, let's say, 1 cubic centimeter. This one would be 8 cubic centimeters. Okay, let's have a look at a couple of examples. Part A. Two similar cylinders have their radii in the ratio 4 to 5. Find the ratio of their volumes. Now we're dealing with a solid, three-dimensional object, so the ratio of their solids will be 4 cubed to 5 cubed. Okay. Instead of 4 squared to 5 squared, obviously that's when we're dealing with area or even surface area, which we're not covering in this video. But if you asked the ratio of the surface areas of three-dimensional objects, it would not be 4 cubed to 5 cubed, it'll be 4 squared to 5 squared. Okay, so just be mindful of that. But anyways, we're after the ratio of their volumes. So 4 cubed is 64 and 5 cubed is 125. So 64 to 125. So 64 units of the smaller cylinder would correspond to 125 units of volume in the larger cylinder. Part B, two similar solids have their volumes in the ratio 125 to 343. If the height of the larger solid is 80 millimeters, find the height of the smaller solid. So this is really just an application of ratios, really, and just manipulation of this ratio. The first thing we need to see is that we're given the ratio of the volumes, which means that we need to take the cube root, first of all, of each term of this ratio. So take the cube root of 125 to the cube root of 343. Okay, so if you're unsure, shift square root button there, just a sort of a quick key there that you could just press or invoke to do the cube root. So that's going to be 5 to 343. Okay, take the cube root of that, which is 7. So in fact, the side lengths, the corresponding side lengths, are in the ratio 5 to 7. Okay. Now we're given that the larger solid is 80 millimeters. So what this means is that the height of the smaller solid to 80 millimeters is in the ratio 5 to 7. Now we could in fact express this as a fraction, so that's x over 80 is equal to 5 over 7. Okay, multiplying both sides by 80, so x is equal to 5 on 7 multiplied by 80. Okay, so 5 on 7 multiplied by 80, and we get 400 on 7, or as a decimal, say 57.14. Right, so x is equal to 57.14 millimeters, correct to 2 decimal places.